Hello everyone. Hope you are doing well. I am Akshay Parmar, Assistant Professor at LJ Institute of Engineering and Technology in IT department. Welcome back to the video tutorial series of the Internet of Things. Right? So in this session, we are going to discuss about the messaging protocol, the constraint application protocol in brief. In our previous session, we have discussed about that MQTT in brief, and in this session, we are discussing about the CoAP. Right? So in this session, first of all, we are discussing about the messaging protocol and its type. So in that, we are covering that constraint application protocol in brief. Right? So let's begin with the constraint application protocol. And before that, what is the messaging protocol according to you? Right? We have discussed about in our previous session. The messaging protocol are very important for the transferring of the data in terms of its message. That protocols are very useful for sending that message to the cloud and receive the data from the cloud in the IoT application. That protocols are very useful for sending that message to the cloud and receive the data from the cloud in the IoT application. So here there are two types of the protocols, right? The first one is an messaging queuing telemetry protocol that we have discussed in our previous session. After that, in this session, we are going to discuss about a constraint application protocol in brief. Right, so let's start with a constraint application protocol. So you have one question arrived. Who have developed that CoAP protocol and where does it use? Right, the CoAP is designed by an IETF to work in a constraint environment. Right, the IETF stands for the Internet Engineering Task Force. The Internet Engineering Task Force. Right, so they have designed this protocol to work in the constraint environment. It is one-to-one communication protocol. The CoAP is lightweight like MQTT protocol and it uses less resources than HTTP. It is one-to-one communication protocol. The CoAP is lightweight like MQTT protocol and it uses less resources than HTTP. The HTTP runs over a TCP and it is in connection oriented. Why? The CoAP runs over an UDP and it is connection-less protocol. Right? This is a basic difference about CoAP and the HTTP. Right? HTTP is run with an TCP/IP and it is connection-oriented, where the CoAP is a connection-less protocol and which is working with an UDP. Right? So let's discuss about the CoAP architecture. The CoAP is based on RESTful architecture. The representational state transfer. The REST approach ensures the secure, fault tolerant and scalable system. Right? The CoAP optimizes the length of the datagram and CoAP is connection-less protocol and it requires the retransmission support. Right? So which is already supporting that. So let's discuss an CoAP layer. So you have one question around. How many layers are there in the CoAP? Right? So CoAP is having an 4 layers. So which are they? The first one is an UDP. Right? So UDP. After that, the second layer is a message. The third layer is a request response. And the fourth layer is obviously an application layer. Right? The message layer is designed to deal with UDP and asynchronous switching. Right? That layer has designed that way. The request and response layer concerns communication method and deal with request and response of that messages. Right? In the request and response layer, the client may use get, put and delete method to transmit the messages. Right? So with the help of that method, that client can send a request and respond to that system. Right? So that are the mainly layer of that particular thing. After that, let's see the message layer in the CoAP. The CoAP message layer supports 4 types of the messages. First one is conformable, or we can say that the reliable messaging, CON. This is reliable approach because the retransmission of the message occurs until that acknowledgement of that same message ID is received. Right? This is an approach. This is a reliable approach because it is allowing that retransmission of the message occurs until the acknowledgement of the same message ID is received. If there is a time out of fail of the acknowledgement, the reset message, RST message, will be sent from the server as a response, right? And the client will retransmit the message. The resolve that retransmission and it is considered as a reliable approach, right? So here the client is server is there. This client is sending in CON message, right, which is addressable. The another type of the message which is supported by the CoAP messaging layer is a non-conformable, right? This is a non-reliable message, or we can say that the non. In this, the message transmission style, there is a no reliability to is assured, right? In this message transmission style, there is no reliability to ensure, right? The acknowledgement is not issued by the server itself. The message has ID for supervision purpose. If the message is not processed by the server itself, it transmits that reset message, right? This sending a non-message to that. The message has ID for supervision purpose. If the message is not processed by the server itself, it transmits that reset message, right? This sending a non-message to that. After that, the third type, that is an acknowledgement. Okay, we are familiar with an ACK message, right? So yes, this message is in this message, the traditional acknowledgement message stands as usual as the protocol, right? In this messaging, this traditional acknowledgement message stands as usual protocol, right? We can compare this with a regular handshaking scheme. The handshake is an automated process that establishes a link for communication before actual data transfer begins, right? So with the help of that, we can ensure that establishment of the link of the communication, right? The fourth one, this is a reset, or we are familiar with an RST message, right? The receiver is expecting that message from the sender of a particular message ID. This message is sent from the sender side, right? If no message is processed or received before a specific amount of time called timeout, the message called reset is transmitted from the receiver, right? After the timeout event, the receiver is sending that reset message to the server itself, right? This message informs the sender that there is a trouble in transmission of that message, right? This message informs the sender that there is a trouble in transmission of that message. That's about a message layer of the CoAP. After that, the request response layer. There is a layer in the CoAP, right? There are the three modes in the CoAP, request and response layer. So which are they? The piggyback. The first one is that in this mode, the client sends the data with a particular method, as we are familiar with an get, put, etc., with a token number and CON messaging. Here, the client is sending a CON message along with that, right? The acknowledgement transmitted by the server immediately with the corresponding token number and the message, right? So here, the acknowledgement is transmitted by the server immediately with the corresponding token number and the messaging, right? If the message is not received by the server of the data is not available, then the failure code is embedded in the acknowledgement, right? So that's how that piggyback is working. After that, the another type is separate response, right? Its name suggests. In this mode, the client sends the data with particular method, right? Get, put, and all that, right? With the token number and the con messaging, right? Here, it is sending that thing, right? If the server is unable to respond immediately, and the acknowledgement will be reverted, right? After some time, when the server is able to send the response, it sends the CON message with the data, right? So here, what is the difference between the piggyback and the separate response? The sending an empty acknowledgement, right? After some time, when the server is able to send the response, it sends the CON message along with that message. In the response to that, the acknowledgement is sent back from the client to the server, right? So this is a response from the client to the server. In the response of the acknowledgement, in the response to that, the acknowledgement is sent back from the client to the server, right? So this is a response from the client to the server. In the response of the acknowledgement, right? After that, the third part, non conformable request and response, right? In this mode, the client sends the data with particular method, right? With the, here, in this mode, the client sends the data with the particular method with the token number and the non-message, right? Annoying messaging method, right? So here, the client is sending that particular method with that along with the token number and the annoying messaging method. The server doesn't give acknowledgement in annoying messaging method, so it will send an annoying type response in return with a token number and its data. So let's discuss the CoAP message format. Right. So there are the various fields in the message of the CoAP. Right. So what is the function of that particular field? We will see. The CoAP message format is of the 16 bit, considering of the various fields. Right. So there are the various fields such as the V, the version, type of the messages, token length, code, message ID, the token. If we require any kind of token, it is a really optional field. After that, and the optional field is there. If we need any optional kind of information, we need to include it there. And at the end, there is a payload, right? So let's see each of the field and what is it indicating that thing, right? This is the first one. The first field is an V, right? It refers to the version of the CoAP, right? It is having a 2-bit unsigned integer, right? So the 3-bit is referring about an CoAP version. After that, the T field, right? It refers the message type, right? So by which kind of message is there, we can identify with the help of that particular field, right? It is also a 2-bit unsigned integer number, right? So what is its value? It may be a 0, 1, 2 and 3, right? 0, 0, 0, 1, 1, 0 and 1, 1, right? If we have a 0, 0 at the field T, we can get to know that there is a message kind of conformable message, right? If there is a 0 in this particular field, we can get to know that this is a conformable message. If there is a 1, it is a non-conformable message. If there is a 3 and 4, it can be an acknowledged and a reset message respectively, right? So with the help of this particular V, we can get the version of the CoAP, and with the help of that P, we can get the type of the messages, right? After that, this token length field is there, right? So what is the function of that field? As its name suggests, it refers to the token length, and it is a 4-bit of the unsigned integer number, right? So with the help of this token length field, we can get to know that what is the length of that particular token if there is if any token is there. After that, the code field is there, right? It refers to the response code, right? It refers to the response code, right? That code field is refers to the response code, and the message ID is there, right? So as this name suggests, what is message ID? It is identifier of the message and avoid the duplication, right? So with the help of that message ID field, we can avoid an duplication, right? It is an identifier of the message, right? After that, this token, right? It is an optional field in the CoAP messages, right? If we need any token whose size we have already defined with the help of this TCAL, the token length field, right? So if there is any token, we can set it in this particular field, and we have one optional field in the CoAP message. If this field is used, if any optional information is available and having the length of the 4 bytes, and the payload is there, right? And at the end, the payload field is there, right? This field refers to the payload data, where the actual data is transmitted, right? So that are all the fields which is included in the CoAP messaging, right? So yes, in this today's session, we are discussing about the messaging protocol, right? So by which we can transmit the data to the cloud and we can get the response from the cloud itself, right? So yes, in our previous session, we have discussed that MQTT protocol, and in this particular session, we have discussed an CoAP protocol in brief, right? That's all about today's session. Thank you for the watching.